Welcome back as we continue our discussions on the subject of advanced automatic process control. Energy costs were an appreciable portion of the overall production costs, and the company next analyzed ways in which it could reduce the cost of producing steam. The engineers knew that the ideal temperature of the mixture should be 80 degrees centigrade to ensure proper blending of the ingredients, and as long as the temperature did not rise above 85 degrees centigrade or fall below 75 degrees centigrade, the product quality would be perfectly acceptable. If the set point, however, could be lowered to 77 degrees centigrade, with a maximum deviation of plus minus 2 degrees about the set point, then the amount of steam required for the blending process could be reduced. But first, they would have to find the cause of the temperature variations. Pressure and temperature meters were installed in the steam supply line, and a pressure meter in the heat exchanger shell. The measurements revealed that the demand for steam in other areas of the plant affected the pressure and temperature of the steam supply to the heat exchanger. When the steam pressure rose, the steam temperature rose, and conversely, when the pressure fell, the temperature fell. These variations were also apparent in the heat exchanger shell. It took some time for the temperature shift to travel through the heat shell and the mixture to the temperature sensor. By the time the sensor reported the temperature change, the product temperature was outside the set point. The PID controller could maintain the temperature within plus minus 5 degrees of the set point, but the delay in the heat transfer from the steam to the sensor prevented it from controlling the temperature more accurately. It was realized that steam pressure was the process variable they could effectively use to speed up the response of the system, since changes in steam pressure always produced variations in steam temperature. This was a case for cascade control. The fundamental principle of cascade control is to use the output signal of one controller to adjust the set point of the second. Let's explain. Within the cascaded control system, we have two control loops, the outer or primary loop and the inner or secondary loop, respectively. The inner loop functions as a normal feedback loop controlling the secondary variable, steam pressure, whilst the outer loop controls the primary variable, product temperature. But instead of positioning the steam valve, the primary controller is used to adjust the set point of the secondary controller. Here's how the cascade control system functioned to keep the temperature of the mixture closer to the set point. The inner, or secondary loop, contains a pressure sensor which monitors the steam pressure in the heat exchanger. Variations in steam pressure are addressed by the secondary controller, causing the steam valve to open and close according to the steam pressure. The outer, or primary loop, still responds to variations in product temperature, but instead of positioning the steam valve, its output is used to adjust the set point of the secondary controller. The secondary controller then repositions the valve whenever its set point is altered. Let's summarize the action of the cascade control system once again. The secondary control loop is active most of the time, regulating the steam flow to the heat exchanger. The control loop functions to minimize disturbances in steam temperature caused by pressure variations in the steam supply. The primary loop, however, responds to load changes in the product, adjusting the set point of the secondary controller whenever a bottling line is started up or shut down. This is how the temperature response looked after the engineers had installed and tuned the new cascade system into the chemical plant. The set point had effectively been lowered by 3 degrees to 77 degrees Celsius, and the temperature variations reduced to plus minus 2 degrees. As a result of the cascade control system, the company was now enjoying the financial benefits of a reduction in energy consumption.